All right, so at this point, you should have done the 4 practice problems. So for number 1, h of x is equal to 25x squared minus 9. This is what we call difference of squares. So I know that in order to factor this, I need to start looking at this like they're perfect squares, because they are. 25's perfect square is 5. 5 times 5 is 25. X squared's perfect square is x. X times x is x squared. And 9's perfect square is 3. 3 times 3 is 9. So it breaks up like this, which means that I know I'm going to have 2 almost identical binomials. The only reason that they're not fully identical is because this is a negative in the middle. And I see I have no b value. I only have an a value and a c value. So since I have no b value, that means it's 0. So I need a positive 3 and a negative 3 in order to cancel that out when I add them. Also, I need a positive 3 and a negative 3 when I multiply to give me a negative 9. So they break up into basically 2 almost identical binomials multiplied, the product of 2 binomials, 5x minus 3, 5x plus 3. Now that I know that, I can find the zeros. I'm going to set 5x minus 3 equal to 0. I'm also lazy, so I usually only do this once because I know that whatever my answer is going to be the same answer twice, but one will be negative and one will be positive. But I'm just going to do it for the sake here. So I set each of these equal to 0, and I'm going to add 3 to both sides here, and I'm going to get 5x equals positive 3. In order to get 5 away from the x, I have to divide by 5 on both sides because it is currently being multiplied. And division is the inverse or opposite operation of multiplication. So I get x equals 3/5. And over here, again, I already know I'm going to get the same thing, but it's going to be negative. So I follow the same exact steps. Whoops. Let's undo that. So it doesn't look like I can move that. So I'll have to just bring this down and you will see the y-intercept, no biggie. Okay, and I get 5x equals negative 3. And I divide again for the same reasoning. And now I see that my other x-intercept, my other 0, is x equals negative 3/5. So those are my two x's. My y-intercept is my constant, negative 9. So that's where that came from. So that's practice problem number 1. So for number 2, this is not a difference of squares problem. I can solve this using GCF, or I could just factor it right out. So I'm going to just factor this one right out so we can get practice with both. Factors of 24 are 1 and 24, 2 times 12, 3 times 8, 4 times 6. And I see automatically 1 and 24 and 3 and 8 will not work. But 2 and 12 I can get 10 from, and 4 and 6 I can get 10 from. But you have to be careful which one you choose because this is a positive 10 and this is a negative 24. And that tells me, this negative 24 tells me I either have to have a negative times a positive or a positive times a negative. I cannot have the signs match. So that eliminates 4 and 6 as an option because they would have to be a positive 4 and a positive 6. So I'm going to be using 2 and 12 here. And I'm going to break this up into the product of 2 binomials, x with 2 and x with 12. And at this point, I just need to determine the signs. Well, this is a positive 10, so my bigger number, 12, is going to be positive. 12 minus 2 gives me 10. And that is its factored form. And if you do that with factoring by grouping, you will get the same answer. So now my zeros, x minus 2, set that equal to 0. I get 0. I get 2, 0. And over here, we know it's going to be the opposite of what we see in the parentheses. And the reason that it's the opposite of what we see in the parentheses is because this is just x. The coefficient of x is 1 here. So when the coefficient of x is 1, you know it's going to be the opposite of what you see in the parentheses. So our zeros are positive 2 and negative 12. And now my y-intercept, I know the y-intercept is the constant. So here, that's negative 24. So my y-intercept is negative 24. All right, moving on. Here are some trickier ones. I definitely want to use factoring by grouping for these. So here, I'm looking first, does it have a GCF? Is there a greatest common factor? The answer is no. So I'm going to use factor by grouping. So I multiply my A times my C value, I get negative 40. And I'm going to say, well, what are the factors of negative 40 that can give me 3, or negative 3, I should say. And that would be 8 times 5. 8 times 5, where 8 is negative and 5 is positive. So that is how I break this up. I have 4x squared minus 8x plus 5x minus 10. And now I do the grouping portion. I ask myself, well, what do they have in common over here? 4x squared and negative 8x. Well, they have 4x in common. So I factor out 4x. And here, 4 divided by 4 is 1. X squared divided by x is x. My subtraction sign comes down. 8 divided by 4 is 2. And x divided by x is 1. That cancels. So now I just need to see, all right, well, what is in common over here? Well, clearly, 5 and 10 both have 5 in common. So I'm going to factor out 5. And I will be left with x, because 5 divided by 5 is 1, minus 10 divided by 5 is 2. And now I'm happy because I got the same terms on the inside, x minus 2. That's what I want, because now that x minus 2 is the greatest common factor, and I can factor that out. When I factor that out, I'm left with 4x plus 5. So those are my factors. Now I need to find the zeros. So I'm going to set x minus 2 equal to 0. Actually, no, I'm not. We know that this will be x equals positive 2. Why? Again, because x's coefficient here is 1, so it's just going to be the opposite when we add it to the other side. But I will solve this one, 4x plus 5. And that's because x does have a coefficient greater than 1 here. Or not equal to 1, I should say, because it could be a negative coefficient as well. So I'm going to subtract 5 from both sides, and I'm going to get 4x equals negative 5. I'm going to divide, do the inverse operation. Whatever I do to one side, I have to do to the other. So I get x is equal to negative 5/4. I get x is equal to negative 5/4. So those are my two zeros. And I can write them like that, and I can also write them as coordinates. All right, now it's asking me for the y-intercept. My y-intercept is my constant. My constant here I can automatically identify by looking at it that it's negative 10. And it's negative 10 because negative 10 is my constant. And I know that negative 10 is the constant because it has not attached to any variable. So my y-intercept is my constant, negative 10. All right, so now we have this last one. Again, I'm looking at it and I do not see a greatest common factor between 2, 9, and 5. So therefore, I'm going to be using factor by grouping. So I multiply my 2 times 5, negative 5, and I get negative 10. So what are the factors of negative 10 that can give me 9? Well, that has to be 10 and negative 1. 10 minus 1 gives me 9, and 10 times negative 1 gives me negative 10. So I bring my first term down, and then I break up my b into positive 10x and negative 1x. And if you remember, I like to write my negative 1 first. Negative 1x plus 10x just makes it easier in the long run. And you could write this as negative 1x or negative x. They'll be the same. So what is the greatest common factor here once I group them? X's. That's what they have in common. So I'm going to factor out x. And once I divide 2x squared by x, I'm left with 2x. My negative sign comes down. And when I divide negative 1x by x, I'm just left with negative 1. Now on the right side, 10x and negative 5, they both have 5 in common. So I'm going to factor out 5. 10x divided by 5 will leave me with 2x. And negative 5 divided by 5 leaves me with negative 1. Again, I see I have the same thing. So I'm happy, and I know I'm on the right track. So now I'm going to factor out 2x minus 1. And I am left with x plus 5. So now to find the zeros, I automatically know that one of my zeros is going to be negative 5, 0, because the coefficient of 1 helps me easily see that if I subtract this to the other side, it's going to be negative 5. So I do need to solve this one though. 2x minus 1 equals 0. I add 1 to both sides, and I get 2x equals 1. Divide both sides by 2. Whatever you do to one side of the equation, you do to the other. And I get x equals 1/2. So 1/2 and negative 5 are my two zeros or x-intercepts. Now for the y-intercept, again, I'm looking for my constant. This is x squared, this has x, this does not have any variable, so since it does not have a variable, it does not change, therefore it is constant. So this one is my constant, negative 5. And that means it is my y-intercept as well. My constant is my y-intercept. So I have a y-intercept at 0, negative 5. I encourage you to go back through this video and make sure that you have a good understanding of how to go from factoring to finding the zeros, as well as identifying the y-intercept.